Okay, let's get started. Agentic DevOps, let's start with a maturity framework so we can prepare our ideas and we can understand how we can improve how we do DevOps and how we can add also AI to this discipline. So if we imagine a level 1 where we just have a script creating the infrastructure we need, it's not very agent ready. Eventually this script needs to be used multiple times, so we split the script from the config, and then eventually we copycat the Terraform model with the life cycle, so we do create and delete. But I would say to become really agent ready, I think we need to introduce 2 new verbs that are validate and describe, and I will explain why. Someone will say, but I am at level 3. Yeah, that's true. Probably most of the companies are using Terraform nowadays, and they use create and delete. But Terraform is just one part of the DevOps ecosystem. I have seen so many companies creating ad hoc scripts, and actually I would say your level of maturity is actually the lowest level that you have. So if you have level 3 for the cloud resources, but the application catalog, for example, is created with a script, or the list of teams or list of departments, I would say you have a combination of level 1, level 2, and level 3, and it's very difficult to find a company that is curating all the resources besides the cloud resources, where you find the provider out of the box with Terraform. Okay, let's describe level 1 is a script. Of course, you don't want to modify a database with the records manually. You don't want to click on the web interface of your service provider. You try to automate things, so you create a script. Then you go to level 2 and you say, I need to use this script multiple times, so let me put a configuration, and eventually you go to level 3 and you say, the resources that I am creating, they have a life cycle, so let me do create and delete as a common interface. And eventually I think we need to start describing validate and describe itself, because this is what unlocks the agentic part. So the idea is that it's very risky to delegate create and delete to an agent, because then the agent can make a mistake, the prompt can be wrong, can be prompt injection, we don't know. But suddenly, if we give create and delete, so we give the same permission of the operator to the agent, we can have incidents. The uptime can go down, and we have seen a lot of articles online about this problem. So what can we ask the agent to do? We can ask the validation. I go in the details what I think is the validation, but we can think is the pre-flight check in airplane. It's something that requires only read-only permission, and it allows us to understand if the create will succeed or not. And then the describe. So describe the real state and the desired state, and show me the differences. So something that we can run before and after, and it will tell us if Terraform plan, for example, is planning for changes, or other resources are not anymore like the desired state. So a create that we can see create and update can be combined in one verb. So the describe will tell us, yes, you need to run the create, or the describe can be used during an incident to provide context to the agent so that he can suggest the next. So this is the idea. So if we reach level 4 and we start with the validate and then we implement even the describe, we really give the agent a lot of context, and he can take this role of advisor that is going to tell us what is the next step, what is the cause of the disruption during an incident, and so on and so forth. So let's have a closer look to the validation. So inside the validation, we can put anything. The idea is that in these scripts, they can execute any kind of operation against the production system, but we can start with the schema. I have seen so many incidents because of a typo in a data structure, in a YAML file. The list of the AWS accounts had a typo. The coercion created an empty list, and then the script was trying to destroy all the AWS accounts with a major incident of many millions. This is something you can avoid with a pre-flight check, with a schema validation, and the agentic coding can really generate this kind of code for you. So there is no reason nowadays not to avoid this pattern, because even the code that is checking the schema can be generated by the agent. The tooling, imagine if you have a package that exposes the validation that needs to be used by someone else. You can help them to provision the commands that are needed to run the package itself. So Terraform, is Terraform available, the correct version, so on and so forth. Credential, same thing, we can ask if the credentials are available, and then some domain specific. So if the package is deploying Docker containers, are these Docker containers available? So you can talk with third-party APIs. If the validation passes, then create should work. If it fails, then create can probably, and then you can create a loop. So the agent can continuously run the validate, try to fix the local environment because he has bash access, of course, inside a sandbox. So in one sentence, we can say DevOps is describe your desired state and run a command to make it happen. And if you think about what is the command that the agent should run, is validate. It's deterministic, safe, and the advantage is that you can create this loop. So the agent continuously run, validate, make changes to the environment because he has bash action, the bash tool, and he cannot make damages because it's running inside a container, a Docker container, so it doesn't see, it sees only the things that we put inside this container in terms of credentials and tools. So that's the operating model that we need to aim. The level 4, it gives a contract, and let's see how to operationalize it. So the idea is that we should not give the agent the same posture of the operator. The agent should advise, and the operator is the one that is actually running create. The command to create this Docker environment is four the parts. npx from node allows you to run executable downloaded from internet. bc-pkg is BigConfig package, and then there is a GitHub repo that is BigConfig package itself, and then shell. So this command will make sure that you just need to have node. It will make sure that you have closure, Bashka, the JDK, and Git. You will download from the repo in GitHub the bb.eden. It will make some changes to bb.eden to keep the lineage, and then it will run shell that actually is a task inside the Babashka. You can think about the bb.eden like a makefile on steroids for closure projects, and this shell will run Docker and it will create this disposable container. It has some facilities, so for example it will copy the .py folder inside the container so that you can have the credential to use your token service like GPT 5.5 codex, your subscription. And then let's think about what are the loops. So we said before, the agent can run in a loop validation until it works, and from validation it will get a to-do list of changes that it needs to fix inside the container. Same thing for the scribe. If we have an incident, it can use the scribe to understand what's going on and give us a feedback. It's always like this. It's comparing the desired state with the actual state before and after. Create will not, if the agent tries to, so this is a compliance by design. So if the agent understands the package, he understands that there is a create and delete. Even if he tries to do create or delete, nothing will happen because it doesn't have the credentials. And create and delete, we just wait for the agent to say, okay, the validation is passing, now you can do create, and then we just run create. Here we could say, why are we running create on the dev machine? Well, if we put GitHub Action in the middle, nothing changes. There is a package in BigConfig to create cloud dev environment. So if there is no difference between a cloud dev environment and a GitHub runner, actually you can run the GitHub runner inside the cloud dev environment, getting a lot of benefits. And I think it's not the pull request that is gonna save the day, but it's actually this level of automation where actually the operator gets the last step that is created, and everything is inside a package, so it's battle tested. You don't modify Terraform, but you just modify the configuration and then run create, and this will transform the desired state in the real state. So what is the golden path? So the operator creates this sandbox. It starts PyDev so that you avoid the theater of security with the agents where you can have a lot of system prompts and user prompts. Please don't destroy anything. Here you have compliance by design and not by behavior, so the agent cannot write production. You ask the agent to describe and validate, and then you receive the recommended next step, and then you can finally decide if it is a good idea to really make the changes. So the boundary are read-only credentials. There's no way that the agent can do delete. And then how can we provide more context to the agent? That can be achieved with ForceCommand. ForceCommand, to make an example, is used very often for continuous delivery. So after the continuous integration is green and you want to deploy the new container to production, one way is to use SSH, and this SSH will push virtually the new release of software to production, making a SSH connection. Now, SSH to production can be too much power, so you can create a force command. So a force command says this SSH user can only run this command, that is actually Docker upgrade the Docker image, and it can now receive a normal shell to run this kind of commands. And force command that is very useful to implement very simple but effective deployment pipeline can be used also with agents. So now we have the agents who can access some commands like kube control to describe the reality, but we need to gate so that it doesn't do the right commands, and this can be achieved with force command. Again, with the coding agent, we can generate a force command that is going to deploy to a machine with a permission. The Docker container doesn't have these kind of permissions, but it has an SSH key to reach this machine. And it's a very simple architecture. I think compared to MCP, it's much simpler. It's something that we are familiar. I think for DevOps, the MCP, unless it's provided by someone else, I would not implement it to create the context for the agent, but I will go with the force command. And I have implemented many force commands, and it was very simple, just a few tokens, and the coding agent was getting the job done. So the list of patterns to follow, I would say run your agent in disposable Docker container. There is a command that I have created to achieve this. Adopt bc-config packages. You can take any Terraform script, any scripts, any DevOps script. You can ask your agent to transform it in a package. Implement the life cycle and the two verbs. Create two pairs of credential, read write. When the read write is the only possible credential, I would say implement the force command. And what else? I mean, none of these ideas are complicated, to be honest. I think, and the anti-pattern that I would avoid, don't run the agent with your permissions, don't give the agent the full credentials, don't implement the verbs. This don't embrace MCP when you can do things with force commands. So back to the summary. Most of the people are using Terraform, and so luckily they are level 3. But if you don't broke this Terraform inside a package, you cannot achieve level 4. And usually Terraform is not enough. You have other systems, so you have other part of the infrastructure that are living probably level 1, level 2. You can bring everything to level 4. You can package things, you can create packages of packages, and you can expose this interface to your ops guys so that they have always the same way of working. During an incident, during the night, it's very important that the interface is very simple: create, delete, validate, describe, and then you can add other commands if needed, like rollback or stuff like that. But the starting point, I would say, is create, delete, validate, and describe. And this approach on how to operate agents are very powerful. They can really slurp a lot of information, create this context, and answer what is the problem of a disruption. But they need to be, I think, operated with some safeguards. So that's it. Thank you very much, and bye-bye.